Hello everybody. Today we will talk about symmetric key cryptography. Okay, so let's start. Today the agenda. First, I will talk what is the symmetric key cryptography and the ancient time cryptography algorithm. And then I talk about the mechanism and also show you an example. Okay, so let's start. So in right now in computerized environment and cryptography is commonly used. We use it daily life. Before that, let me explain some basic concepts. First is called plain text. Plain text, which means just a normal text, which what the letter, the essay you write, and which can be readable. Also has some meaning, okay, which in cryptography is called unencrypted text. Okay, so ciphertext. Ciphertext is encrypted data or encrypted text, which means usually is not readable. Okay, so didn't have any meaning. That's for secrecy. And encryption is the process by in which plain text is converted into ciphertext, which is the process to convert a human readable plain text into a ciphertext, which usually is not readable. Decryption. Decryption is the opposite. It's the process of recovering plain text from a ciphertext, which is the inverse process of encryption. The final term is called cryptography. Cryptography it is the process that hides and reveals information to prevent third parties or the public from reading private messages, which means cryptography includes both encryption process and decryption process. Okay, so that's today's topic, symmetric key cryptography. What is a symmetric key cryptography? So after understanding the basic concept, let me explain what is the symmetric key cryptography or symmetric key algorithm. Symmetric key algorithm, this concept or this term is identical to single key algorithm or private key algorithm. These three terms are identical. Okay, so then what is the single key algorithm? Basically, from the name, you can understand this algorithm is encrypted and decrypted by using the same key, which is a single key. Okay, so it's the algorithm for cryptography that uses the same key for both the encryption of plain text and the decryption of ciphertext. So the diagram here just show you how it works. Okay, so and in cryptography, usually it's a two-sided with sender and recipient. The two sides involved with the sender and encrypt the plain text by using the single key and then send out to the recipient. The recipient will use the same key to decrypt the data and to decrypt the ciphertext, and then the recipient can read the original plain text. Okay, so this is called a symmetric key algorithm. In fact, this idea or this algorithm, before the computer had been invented, in ancient time, we already used this algorithm. Okay, for example, and there's the keyword, and it's called a Caesar cipher. Okay, Caesar cipher is exactly an example of symmetric key cryptography. Okay, so with the Caesar cipher and is a kind of a substitution cipher in which the alphabet, which is, for example, English 26th alphabet, in the plain text is shifted by fixed number down the alphabet. For example, if you look at this diagram, you can see here the top row is plain text, then it's 3-letter shift, then A shift to C, B shift to D, and so on. So which means whenever the plain text in letter in A in plain text, it will convert to C. And if the letter in plain text B, it will convert to D, and so on. Okay, that's called encryption. The decryption is the opposite, which means whenever a letter in ciphertext is C, then that will convert to A. Okay, so if a letter in ciphertext is D, that will convert to B, which will do the reverse. For example, in Cedar cipher, if the word is a cat, okay, this short word, then if you use the Cedar cipher, you can convert this cat to this CECV, okay, because A converts to C, B converts to E, and A converts to C again, then T converts to V. Okay, so another example, if the are you ready, this sentence, by applying this Cedar cipher 3-letter shift, you will get this answer. See, by looking this, if you do not understand how it converted, then you will not understand the meaning, right? CTG, AQW, what it is, right? So, but if you understand the algorithm, you will immediately understand, oh, this is the represent, are you ready? Okay, so that's called Cedar cipher, which 1,000 years ago, the Cedar is invented this algorithm. Okay, so another example in ancient time is called a visionary cipher. Okay, visionary cipher is also a type of substitution cipher in which plain text is substituted with ciphertext based on plain text and a given key. Okay, so which here it's not a letter shift. Instead of a letter shift like a Cedar cipher, it is in 2 dimensions. One is like English 26 letters. For example, the first column. Okay, that's a 26 letter. That's one dimension. And also in the first row, that's another dimension, which is represent the key. Okay, represent the key. Okay, so which means that the ciphertext or the letter in ciphertext will be defined based on the plain text and the given key. For example, here's the word cat. If you have a key house, then the first column is the plain text, which is input original text. The first row is the key. So let's find out the first letter, C, cat. The C here, right? It's here. Then we found the first letter for key, H. H is here. So the intersection of C and H is J, right? Letter J, which we found one letter, J. That's J is part of the ciphertext, the first letter. Then we see the second one, A, cat A. The key second letter O, O here, O and A, the intersection of O and A is O. Then the O, we found O. The third one, T, the plain text letter the T, and with the key the U, the third letter the U here. Intersection of T is N, right? Jon. So the cat by applying this visionary cipher, it becomes JON. Okay, so which is another type of ancient time algorithm. Okay, so that's the ancient time symmetric key algorithm. Let me show you example of the symmetric key algorithm in computerized environment. So we know there's the AND operation, OR operation, and XOR logic, or and Boolean type of operation logic, right? So which the OR operation is like this: whenever two input is the same, the output will be 0. Okay? So whenever the two input is different, output will be which is 1. Okay, so that's the XOR. Basically, you can use the XOR to perform and program it to perform encryption and decryption. Okay, that's a simple way. Okay, for example, I give you an example. You have this plain text, for example. It's in binary form. Of course, in computer, all the number is binary, right? So 00110101. That's plain text. You have a key. You have a key that's called a single key. Okay, this key you can give any of them, like here. For example, you define the key the 11100011. Then you do XOR operation between the text and the secret key. Then you got this cyber text. Okay, so after the XOR operation, right? So you can see whenever the two, which is the plain text and the secret key is different, then it will be 1. If the plain text and the secret key is the same, it will out 0. Right? Then you got a cyber text. Okay, so then that's the encryption. Decryption is the opposite, right? You have the cyber text, then you know the secret key, right? Same. Then you do the same XOR operation. Okay, here you do the same XOR operation. That's a simple algorithm. Okay, then you will get the plain text exactly the same. So why this work? First, for this example, you need to decide the length of a plain text, like how many bytes, how many bits. Here I used 1 byte, and you also can use 2 bytes. Then if you use 2 bytes, then the secret key also must be 2 bytes, which must be same length for the plain text. Okay, so or the block of a plain text. Here, I would like to ask you why the simple XOR operation can perform this kind of encryption and decryption. Why it works? The theory is like this. Okay, if you apply XOR, that all depend on XOR operation the property. Okay, for example, any number x XOR here the parentheses plus parentheses again is represent XOR operation. Any number x or 0, it will be the number, didn't change, right? Based on the definition, right? So any number XOR itself, it will become 0 because whenever two input the same, the output will be 0, right? That's the definition for XOR. So also XOR satisfies the associative property, which means if you XOR X, Y, Z, the 3 numbers, then you first XOR X, Y, then XOR Z. The result will equal to you XOR Y and Z first, then XOR X. The result will not change. That's called associative. XOR commutative, which you X and Y XOR X come first and equal to Y, Y put Y in the first, Y XOR X, totally same. So by using this property, we can prove why the previous page, the XOR operation can perform encryption and decryption. Okay, just as long as the secret key is the same. So let's use what we explained plain text, like P represents plain text, C represents cipher text, K represents the symmetric key or single key. Okay, the parentheses plus represent the XOR operation. Then we use the suppose, the first encryption is the plain text XOR key, right? XOR key XOR plain text, that's the same. Then we have plain text C. The two sides we XOR the key again. See, K XOR C equal to K XOR K XOR P, right? So then we apply the associative, so which here there's a two K XOR K and XOR P. We add the associative property K XOR K equal to 0, right? Then the right side becomes 0 XOR P, which apply the property again will equal to P. The left side will be K XOR ciphertext, right? Then, therefore, we got a P plain text equal to K XOR ciphertext C. That's the theorem. So that's why you perform in the previous page, you perform the XOR operation. You can encrypt the plain text. Then you do use the same key to perform XOR operation again, you got a plain text. Okay, so by applying the property of XOR, okay, that's how it works. Okay, so let's do a summary. Today we talk about the concept of symmetric key algorithm, and we talked the two ancient time symmetric key algorithm, Caesar cipher, Virginary cipher, and also I talked the basic symmetric key algorithm, which by applying XOR. Okay, so and I hope you got a better understanding about what is the symmetric key algorithm. Thank you.